Let's talk about what you're going to learn in this class. I'm a regular listener of the Not So Standard Deviations podcast. It's a great podcast that talks about how to do data science at scale in the real world. One thing I learned on the podcast is that scientists sometimes don't get their data from a nice, clean database. That was a real revelation to me. Sometimes people get their data from really dirty text files that don't necessarily conform to the format data should be in when you need to analyze it. I also found out that there is a large number of people working with data that have zero SQL skills. That literally makes no sense to me. Even if your data originally came in a dirty flat file, you should still want to clean it up and put it in a database somewhere. It really is the easiest and quickest way to store and retrieve data. In order to do that, you're going to need to learn some SQL. SQL is a simple yet powerful language, but you don't need to know everything about SQL to use it. Most database vendors take basic SQL and add stuff to it for their particular database software. We're not going to go that deep. We're going to focus on what's called ANSI SQL. That's ANSI. Don't know what it stands for. Doesn't matter. The main thing is that's the word for the SQL standard that at a minimum every database vendor needs to comply with. And we're not even going to go over the entire standard either. We're just going to focus on those things that you need to know to pull data out of a database so you can work with it in R or Python. It depends on the size of your organization, but in all likelihood, you won't be doing data science in isolation. You won't even be doing data science working solely within your data science team. There are a bunch of different professions you'll be working with to deliver data solutions. Learning SQL will help you better integrate with that workflow. Moving data through an organization can be really simple or really complex. On the complex end of the spectrum, there could be various different database technologies involved. There could be streaming systems, batch systems, modeling, predictive, and feedback systems. You could be tasked with creating predictive models that run overnight against historical data and feed those results to a transactional system. You could work further upstream creating recommender systems. No matter where you work in the pipeline, you're probably going to need SQL at some point. This is an example workflow. This is actually the workflow I use in my day-to-day because I usually work as a one-man army. It's really simple and not at all reflective of what might be found in a larger organization. In general, what is happening is data sources are on the left, data delivery systems are on the right. In the middle is all the spindle, fold, mutilate necessary to clean and conform the data for the necessary analysis. I've got it broken out between clean data and messy data. Clean data usually comes from a database of some sort, where there is already a structure laid over the data. If it's from a relational database, it could be highly structured. Even if it comes from a NoSQL database, it will still have some sort of structure to it, even if that structure isn't permanent. Messy data has no structure. Mostly this involves free-form text. Since I know SQL, I can create this entire pipeline. This course assumes that you'll be working further to the right, nearer the delivery end of the spectrum. How this process works is I collect data from all the sources and clean up with SQL. I then dump them in a Kimball-style data warehouse. From there, I'll create special queries called views and stored procs. These are basically data sets that I can call over and over. It's necessary to do this because queries can be hundreds of lines long, and obviously, you don't want to have to write that over and over. There is also a performance incentive. When you create a proc or a view, the database will cache the results, which makes retrieval much, much faster. From there, I can finally start doing some data science. I'll do my analysis and shazam! Present the results to executives. Here's an example of a more complex workflow. It's the same pattern as the simple workflow, but with far more pieces and far more automation. I know some of this looks like Chinese, so I'll explain some of the parts. Scoop, Kafka, and Flume are data ingestion software. Storm and Spark are real-time data processing systems. HDFS and Hive are storage systems. Pig is a data processing language. HiveQL is the Hive implementation of SQL. Just like regular SQL, you can use it to transform data. Hive, Solar, and HBase are data storage and retrieval systems. So from left to right, pull, process, store, present. In this scenario, there is an opportunity for a data scientist to work closer to the source of data. Spark is a distributed in-memory data processing tool. It It allows you to create predictive models using large amounts of data. You can create your model by analyzing data in Hadoop and deploy it over real-time data systems. This is how a lot of the most popular websites can do things like make recommendations to users. Spark also has an implementation of SQL, which we'll take a look at in lab later. The bottom line is, if you want to work in data, you're going to need to know some SQL. It will make your life so much easier. Since this is a crash course, the class is pretty basic. I'll introduce you to databases and database theory. I'll show you how to read a database diagram so you can get the data you need without having to ask someone in IT. I'll show you some basic SQL commands. I'm going to give you enough information so if you need to do something difficult, you can combine concepts and synthesize your own complex query. I'll show you examples and give you the opportunity to apply the concepts you've learned. Finally, we'll connect to some data and do some actual data science with the data we pull from our SQL queries. You'll need some software to successfully complete this course. All of these things are freely available open-source software. Databricks is an Apache Spark cloud solution. There is a free community edition, and we'll be using that for the course. If you'd like to dive deeper into SQL, I'd recommend Sam's Teach Yourself SQL in 10 Minutes. This book got me through undergrad and the first few years of my career. It's been updated in the nearly 20 years since I went to college. I'd still recommend it as a desk reference to anybody that wants to run data for a living.